Hello, welcome to this lecture video. So today we will be talking about systems of linear equation. But first, of course, we have to define what is a linear equation. So when we, of course, talk about a linear equation, it means that we are dealing with highest degree 1. So let's consider linear equation. So given this equation, a sub 1 plus b sub a sub 1 x plus b sub 1 y is equal to c sub 1, or we can actually remove the super subscript 1, or generally ax plus by is equal to c. So we know that when we talk about linear equations, a, b, c are constant. It's a constant, while x and y are unknown variables. We can still extend that ax plus by plus cz, but of course here we will just limit it into two variables. So our variables x and y. Now, if we will call it a system of linear equations, then it means that we're going to consider two linear equations. So systems of linear equations. So we have, let's say equation 1 is a1x plus b1y is equal to C1, and equation 2 is equal to A sub 2x plus B sub 2y is equal to C sub 2. Now we have different types of systems of linear equation, which depends on the value that we're going to find, or the so-called solution. So it is called solution whenever, let's say, for example, the value of x here is the same as x in our equation 2, and the value of y in our equation 1 is also the same as equation 2. Or in other words, e sub 1 will intersect at e sub 2. But that is just one particular type of system of linear equation. Now, to have a better view about this, so let's have an example. So let's remove this first. So let's consider the different types of equations. So let's have number 1. So let's understand what is the so-called inconsistent type of equation. So when do we say that it is inconsistent equation? When equation 1 and equation 2 has no solution. So which means the intersection of e sub 1, equation 1, and equation 2 is empty. And to determine if we are given two equation, we can use the ratio test for us to know whether our variable is, or rather, if our system of linear equation is inconsistent type. That is, when a sub 1 over a sub 2 is equal to b sub 1 all over b sub 2, but it is not equal to c sub 1 over c sub 2. So an example of this is 2x plus y is equal to 8, and 6x plus 3y is equal to 33. So let's identify what is the a sub 1. So we know, of course, that these are the a, and here y means that it is 1y. These are the b, and these are the c. So 2 over 6 a sub 1 over a sub 2 is equal to, let's see if it is equal to b sub 1, which is 1 over 3, and it is not equal to 8 over 33. So if we're going to round this, and this is equal to, or rather if we're going to simplify this is 1/3 is equal to 1/3, and it's of course not equal to 8/33, which means that this two line will not meet. So to show this, let's consider a graphing calculator. So I was able to consider an online calculator here. So first, this is called desmos.com-calculator. I just place here the equation. So 2x plus y is equal to 8. And the other one is 6x plus 3y is equal to 33. It's so very, it's too near, but as shown here, they will not meet. So they are parallel lines. So no matter what happens, these two lines will never meet. So they are called inconsistent linear equation. Now let's go back. What if our equation, so let's delete this and let's consider another example. And this example is for our second type of equation, system of linear equation. Our second type is the dependent type. So if it is called dependent whenever the solution is, so for the first one, the solution is empty. For this one, the solution contains infinite numbers, which means all actually of the numbers that you substitute for x and for the second equation will overlap, or they are the so-called two coinciding or coincident lines. How can we determine that our equation now for a system of linear equation is dependent? So that is if our a sub 1 over a sub 2 is equal to b sub 1 over b sub 2, which is also equal to c sub 1 over c sub 2. So using again ratio test. So if we have here, for instance, example, so let's say x plus y is equal to 4, equation number 1. And for equation number 2, let's have 2x plus 2y is equal to 8. So if we are going to get a sub 1 over a sub 2, that's 1/2. Again, b sub 1 over b sub 2. This is of course 1 and 1. This is 1/2, 1/2, and 4/8. And 4/8 is also, of course, this is the same as 1/2. So we can see here that our equations or our ratio are all equal. So to verify or just to visualize this, we are going to consider again our calculator. So let's place the equation. So x plus y is equal to 4. And the second equation is 2x plus 2y is equal to 8. So the two lines overlap. So if you can, again, if I remove this, you can see here that the green represents x plus y is equal to 4. And when I place 2x plus 2y, it turns into purple. So the purple here indicates that that's the equation. And it is exactly the same equation that we, of course, constructed for x plus y is equal to 4. Or if you notice, the second equation is just, the first equation is just multiplied by 2. So if you multiply this by 2, it's 2x plus 2y is equal to 8. So if you can, of course, observe that already, even if you're not going to use the ratio test, for sure that the two lines are overlapping or they coincide. So it is, of course, a dependent type of system of linear equation. So going back to our next example, so let's consider another example. So again, I'll remove this. For our third example, and this example is an example for consistent. So let us also consider the third type, which is the consistent type. So for consistent type, it contains only one solution. So which means equation 1 will intersect at exactly one point with, of course, our equation number 2. Now, using the ratio test, this is when a sub 1 over a sub 2 is not equal to b sub 1 all over b sub 2. So for the consistent type, we're not going to consider C anymore. So it's a sub 1 over a sub 2 is not equal to b sub 1 all over b sub 2. So for this example, we will be considering equation 1 is equal to x plus 2y is equal to 16, and equation 2 is 2x plus y is equal to 11. So let's have, this is of course 1/2 and 2/1. So 1/2 is definitely not equal to 1. So the equation is consistent. So looking at our figure here, if we will just, of course, change our equations, the encoded equations here, and place x plus 2y is equal to 16, and the other one, so they are also consistent. They meet at -8 over 12. But using, of course, our example, 2x plus y is equal to 11. So this is their intersection point. It is 2, 7. So as mentioned, we have three types of system of linear equation: the consistent type, the dependent type, and the inconsistent type. So thank you for watching. So I'll see you again in our next lesson. Okay, bye-bye.